All right. All right. Compound. What's compound mean? Together. Two or more, right? So if I have compound words, it's one word but made of two or more, right? Okay. So compound inequalities is still an inequality, but it's made up of, in this case, two inequalities. Okay, two separate smaller inequalities. So inequalities include two statements of inequality at once. It says the two inequalities are joined by the words and or the word or. Okay. And the word and means something completely different than the word or. Okay. And this is going to be a huge component to a lot of stuff that you do in mathematics. So it's important for us to come over here to the side and interpret what the word and means. Okay. And means the intersection or overlap. It is the values that are shared by both statements. Or you might hear me use the phrase that they are in common. Okay? Intersection or overlap, that's what the word and means to us. There is a notation sometimes that we use. Is that upside down looking U or horseshoe looking thing? Okay. And I'll write here what or means for us. All right, so the word or, we refer to that as a union, okay? And when we union things, we attach them together. Does that make sense? Okay. So it's all of statement A, and usually we'll be talking about the solutions. So all of the solutions for statement A, along with all of the solutions to statement B, would be our solutions to the overall or statement or inequality. Okay. The symbol for or the symbol for union is what looks like a U. Okay. Now those two symbols have like different names. I don't know what they are, but you guys know like the hashtag symbol is actually called the pound symbol, right? Okay. Like the and symbol. You may know what this is called. Let's see here if I can draw it right. You guys know what that's called? It's called an ampersand. Okay. Like you've got an asterisk, right? The little star thing. Okay. So there are names for that U and the upside down U, but I don't know what they are. The way I remember them, how do we, this one's a union, right? Union, and that looks like a U, correct? So that's how I remember which one's which, okay? This one's intersection, and this one kind of looks like an N, right? Intersection. So those might be some ways of linking them in your mind to remember which one's which. I don't know how much we'll use that as we go through the course, but it does pop up every once in a while. They use these symbols, and then we're like, well, what do those mean? We've never seen those before. This is where we introduce them, but we don't, in this section, use them a lot, but they will come up, like I said, later on. And that idea allows us to solve these inequalities. So each of the inequalities that we solve inside this section, or inside these examples, is going to be exactly what we did last week. Okay? There's nothing different in solving the individual inequalities. It's presenting our answers that's a little bit different. Okay? And presenting our answers is all about understanding what this word right here means. Okay? So first thing I want to do is I want to go through and I want to solve both these inequalities. Okay? So we're going to be looking for X values that are going to make that blue inequality true, and at the same time, they make the yellow one true. Okay? If there's a value that makes the blue one true but makes the yellow one false, it's not a solution. Because the word and says that X needs to make them both true at the same time. Does that make sense? Okay. So what we do is we just go through and we solve for X in that blue one. Okay. So first thing you do is what here in this blue one? If I was going to solve this like an equation, you're going to try to isolate the variable term, right? So you're going to get that thing right there by itself, correct? So you need to subtract 1 from both sides. So we get 6 is less than 2x. Then you're going to divide both sides by 2, right? And I get 3 is less than x. Now if I say 3 is less than x, I could, let's make the argument, like I could say that Austin is younger than Mr. Fay. How could I flip that statement around so I don't lose what information I gave you, but the phrase sounds completely different? If Austin is younger than Mr. Fay, you could say, flip it around, so you talk about me first. You say Mr. Fay is older than Austin, right? Okay. So if I want to talk about my variable first, right now it says 3 is less than x. If I want to talk about my variable first, I got to say x is greater than 3. Does that make sense? Okay. I like to do that. You're going to see me do that all the time when we solve inequalities and the variable does not show up first. I will rewrite it. Make sure when you rewrite it, it's called the symmetric property. When you flip them, okay, that the inequality symbol is still pointing to the same value before you flipped it and after you flipped it. So here it's still pointing to the 3, and when I flipped it, it's still pointing to the 3. Does that make sense? Okay. So saying 3 is less than x is identical to saying that x is greater than 3. Okay. Now I'm going to go through and I'm going to solve for this yellow one. So what I'm going to do to solve for this yellow one? Just going to divide both sides by 3. Did you guys agree with that? Okay, so divide that by 3, divide that by 3, x to be less than or equal to 18. Okay, so that's good. It's already solved for right away. X is coming first. I'm going to move that solution down in line with my other solution because there should be the word and between them, right? Okay. So what I want to be able to do is I want to be able to identify the values that are bigger than 3, and these are the values for x, that are bigger than 3 and less than or equal to 18. Does that make sense? Okay, so bigger than 3 and less than or equal to 18. So numbers like 5, is that bigger than 3? Is it less than or equal to 18? Yeah, number 7. Is 7 bigger than 3? Is it less than or equal to 18? What about 25? Is it bigger than 3? And less than or equal to 18? It's not less than or equal to 18, right? So that number needs to be kicked out. So when we graph this, we need to pay attention to that kind of thing. Oh, it should be, I'm sorry. Good call. Thank you. Where are you at on that one? Austin? Noah? Huh? You're good. So if you see something like that and you know, like I make mistakes like that often. If you see, so just right away, just throw it out. You don't have to raise your hand. Just throw it out. Say, hey, that's wrong. Because I don't want to explain something and then have to go back and re-explain it because I was wrong. Does that make sense? So now when I say a number like bigger than 3 and less than or equal to 6, so 5, still bigger than 3 and less than or equal to 6, right? But I think the next option I chose was 7, correct? Is x bigger than 3? Is 7 bigger than 3? Yeah. But is it less than or equal to 6? No. Okay. So it has to meet those conditions both at the same time. So graphing these, this is the way that is the safest to graph and statements. You're going to find these two numbers on your number line. So like I said earlier, my number lines, I don't make them really detailed. I don't put like, 0 and then 1, 2, 3, 4, 5, 6, 7, 8. I don't usually do that. 4, 5, 6. I would usually just put like 3 down, and I know then 6 is to the right of it, right? So somewhere to the right of 3, I would put 6, and those would usually be the only two values that I write on my number line. Okay. You can do what system works best for you, what makes sense for you, but that's usually the way you'll see me do most of our examples. Okay. Once you have that, the next thing you're going to do is you're going to graph just this blue one. You're going to graph just x is greater than 3. So I'm going to find 3. Okay, now greater than meant that I have to use an open dot, right? Okay, so put an open dot on 3. And now this is the reason I like to have the variable written first, because now the inequality is an arrow of where I need to graph that are numbers that are bigger than 3. Okay. Just for my notes, I like to, when I go from an inequality statement in algebra to the graph, I like to label my graph as much as I can so I can just quickly look at that and say, okay, what did that blue line mean to me? Oh, that was the x is greater than 3 inequality. I'm going to do the red one. So the red one says x is less than or equal to 6. So at 6, I have a closed dot now because of the equality part. And we would shade that way. And everything in red then exhibits that characteristic of being less than or equal to 6. Okay, so those were the two individual inequalities. Okay, now what we want to do is we want to actually find our solution. So I'll do this in green here. Remember what and meant. And over here was the intersection or the overlap, right? If I were to put these two blue and red ones on top of each other, do you see that they start overlapping right there at 3? And then everywhere up into including 6, they also overlap. Does that kind of make sense? Right there at 3, that had to be make sure that's an open dot, and 6 was a closed dot. Come on. There you go. And what is in green there is our solution. So what we need to do next is we need to write our solution as one concise statement, and we usually take the word "and" out. Okay? So this is the way we do this. We go from 3, and then we say less than, and we use the variable, and we go less than or equal to, and then we say 6. So these 2 points here, 3 and 6, those are endpoints of our solution. Okay? Those inequality symbols, when we write it this way, those will always be pointing to the left. They never point to the right. Okay? One of them is never to the left, one's never to the right. Okay? They're always written to the left. Okay? Pointing to the left. Okay? But what we do is we say, well, 3 is less than x, and x is less than or equal to 6. That's an alternative way of reading that. Okay? So I need you to, because you're going to see different formats in homework, solutions and how you type them in, and different formats in how they present the questions to you. But this right here, and this right here are equivalent ways of saying the exact same thing. And we need to be able to move back and forth between the two. Because like I said, the authors will move back and forth between the two. Is that all right? Have you guys seen that before? Yes? No? Never? Well, what were you doing last year? Sleeping. What did you do the year before? All right, so let's do this one. All right, so what's the word here? Or. So that means something different, right? So I just got to keep that in mind. Now, it only means something different to us in regards to when we graph at the end and how we write our answer at the end. The solving for K in this is going to be the same as what it's been in all the other problems. Okay? So, we're going to try to isolate K. So in this first one, okay, in this blue one, I'm going to subtract 7 from both sides. That's going to give me K to be greater than or equal to -1. Then in solving this yellow one, I'm going to subtract 8 from both sides, right? So K is less than -5. So we go to our graph, find -5 and -1. So I'm just going to put -5 there. It's further to the left than -1. So that's usually how I do my number lines. Okay? I think at this stage we all should know what happens to the left -5, what happens between -5 and -1, and what happens to the right of -1. Now I'm going to graph K is greater than or equal to -1. So greater than or equal to means I need a closed dot, right? And then we shade to the right. K is less than -5 is an open dot. And we shade to the left. With or statements, I'd say probably 95% of the time, you're not going to write an alternative answer like we did with the and statements. Okay? So there's not a different way of basically rewriting our solution without the word or. The solution has to be k is greater than or equal to -1 or k is less than -5. That's the only thing that we can do. Okay, so here we're done. But think about what the answers mean there. Okay, if I choose a number like, let's say 0 is over here, right? If I choose 0, that means 0 either makes this one or it makes that one true. It doesn't make both of them true. It only makes one of them true. Okay? So if I plug 0 in, I get 7 is greater than or equal to 6. Is that true? Is 7 greater than or equal to 6? It is true, right? So it makes a true statement. So if k is 0, this one would be true. If k were 0 here, it gives 8 is less than 3. That's false, right? But because it says or, it means that your solution of x only has to make one of them true. Okay? So everything to the right of -1, all of these solutions over here are going to make this first one true. They will all make that last one false. Okay? If I choose numbers over here, okay, so let's choose like -10. If I go 7 plus -10, that gives me -3. Is -3 greater than or equal to 6? That's false there, right? But if I try -10 and this one, is 8 minus 10 less than 3? Is -2 less than 3? So that gives me a true statement there. So any of these values over here make this yellow one true, but make the blue one false. But because it says or, only one of them needs to be satisfied. Only one of them needs to show up to be true. Is that all right? Okay. At any time, and we might see some examples here, but I want to make sure that I get this stated for you before the bell rings at any time. If we don't see an example before then. Let's say I've got my number line here, and let's say I have an and statement, but I graph things in, they look like this when I graph them. A separate graphs, and they look like that. Okay? How many places do those two things overlap when I say and? Is there any intersection between these yellow things? But then that's what we're looking for, is the intersection with the word and, right? So if this was the image that we got, but the word was and, we would make that conclusion that there is no overlap, so that there would be no solution. Does that make sense? Okay. If we did something like this, let's say we had our number line, and let's say one of our solution sets looks like that, and the other one maybe looks like that, and I'm using the word and again. Do you see that they only start overlapping, like right there? So that would just, the answer for that would just be whatever that number is. So let's say this is like 3, and that's 7. And I said x is greater than 3, and x is greater than or equal to 7. Well, to make both of those true at the same time, I only need to write that x is greater than or equal to 7, because that is the only time that the values are bigger than 7 and bigger than 3. Does that make sense? Okay, so there are little intricacies, little caveats with some of these questions that a lot of people think, well, if I see an or statement, my answer should always look like this. It doesn't. Okay, there might be little special cases. And when I see an and statement, my answer should always look like something like this. Well, we just saw an example. If they're both going in the same direction, that you don't write it as this here. Okay, we call that a between statement here. What'd you say? Wednesday. Let's see here. We could have things like this. Let's say we're looking at or. So the word is or. And we have things that are going this direction. And then we have things that are going that direction. Okay? Or means that when we find our final answer, that we include everything from both. Does that make sense? Will there be any numbers here that don't get included in my solutions? If you end up with solutions that look like this, you graph and you get solutions like this, and you're using the word or, then your answer, this will yield all real numbers. That would be your answer. Okay? So my hope is that when you're going through your homework, you've got maybe these things beside, and you can look at specific pictures of what you've done in your homework, and when you got to make a conclusion about an answer and you're stuck, maybe you can come look at picture 1, picture 2, picture 3, and then these examples that we've already done, picture 4 and picture 5, that might lead you to how you're supposed to write your answer. Okay? Let's do see here. Let's do something like this. So we can say, okay, I'm going to write an and statement, but I'm going to write it as a between statement. I'm going to write it visually a little bit differently. So let's say that I have 7 is less than or equal to, let's just say x plus 3, and x plus 3 is less than 15. Okay? Now, this is a little bit different than the last example that we did that had the word and in it, because what do you recognize about this part and that part of the two inequalities? They're the same? Okay? So, if they're the same, we should be able to do something like this. We should be able to take that phrase, that didn't work the way I wanted it to. Won't let me cut and paste the way I want to. But we should be able to take that phrase and this phrase and merge them together so that you only see the x plus 3 written once. Okay? Guys, you guys need to get stuff out and write things down. Okay? Just watching does not help at all. Okay? If we were solving this in this first way I wrote this first format, you would subtract 3 from both sides here to solve for x, right? Okay? And then over here, to solve for x, would you do the exact same thing as subtracting 3 right away? And that's the reason why, because that's redundant. That's the reason why we would write it this way, so that we can now just say, well, I'm going to subtract 3 from the middle, because I'm still trying to isolate the variable. I'm going to subtract 3 from the left, and I'll subtract 3 from the right. So when you have this is called a between statement, because x plus 3 is between 7 and 15 on your number line. What you do to the middle, you have to do to all 3 parts then. Left, right, and middle. So subtract 3, and that's going to give me 4 here, less than or equal to. So this thing here becomes x, and then this thing here becomes 12, right? So we create our number line, okay? The nice thing about this is that because it's already structured as a between statement, when you graph it, you don't need to graph all three parts. You could graph this right there all by itself and say, okay, well, x is bigger than 4. So I find 4, and I'm going to shade it in. I'm going to graph to the right. That's bigger than 4. Then you can graph this one. X is less than or equal to 12. So I find 12, and I say less than or equal to 12. So it'd be that. But the overlap is what we're looking for, right? Because it's and, so the overlap would be between 4 and 12. Doesn't this already tell you, because x is in the middle, you can jump straight to that green answer without drawing the black parts of your graph? Because it says x, and it gives you the two starting points, or the ending points, starting point and ending point, 4 and 12. Okay? And then x is between those. And remember, x is your solution. Is everybody okay with that idea? So you can jump straight from what I've got highlighted here as my answer. I don't need these lines here. I can go straight to this as my answer. And that means no matter what number you choose, give me a number between 4 and 12. 8. Would you guys agree if I wrote it this way? X is 8. If I read that, is 4 less than or equal to 8? Yep. And if I read this one, is 8 less than or equal to 12? Yep. So 8 satisfies both those. Kind of make sense? Okay. The argument here about this section, we're not learning any new algebra. We're not learning how to do, isolating variables, solve for variables, that kind of stuff. We're taking what we already know with that and structuring it to show solutions, and the structure to show infinite solutions. Okay? Because there's an infinite number of values between 4 and 12, right? There's no way if I asked you to write them all down in a list that you'd be able to do that. All right? Questions on this? We can do this? All right? If, the way I've done this example, let's do one real quick. We won't graph it. But if I had like negative 10 less than or equal to 2 times x plus 3 less than or equal to 14, what would you do first here? Let's say this part here wasn't there. So you just had negative 10 less than or equal to 2x plus 3. If you just had that, how would you solve? Distribute? Okay. So it's the same thing then when it's like this. You're still going to distribute that 2. You're still going to go 2x and 6. So we got negative 10 less than or equal to 2x plus 6 less than or equal to 14. Now what would you do to try to get your variable term, trying to get that by itself? What are you going to do with that 6? So you subtract 6 here, subtract 6 there, subtract 6 there. You get negative 16 less than or equal to 2x less than or equal to 8, right? And now what would you do to solve for x? Still divide by 2? So divide by 2 by all three parts. And we get something like that. Okay? But the algebra, if you can look at that and say, okay, what would I do if it was an equation? Answer that. Then that's the same thing that you're going to do when it's an inequality. Okay? Same exact procedure.